There is something on the moon that we can use that has great value because it's usable in space. And the big discovery here is the discovery of either water ice or significant amounts of hydrogen in the dark areas near the poles of the moon. Now fundamentally what we found from the Apollo missions is the moon is very dry. It doesn't have very much water. In fact, it's depleted in volatile elements in general. But it does have areas near the poles that are in permanent darkness. The reason it has this is the moon's spin axis is normal to the plane that it orbits the sun. Earth's spin axis isn't. Earth's spin axis is tilted about 20 degrees off the vertical, and because of that we have seasons. The moon has no seasons. Near the poles of the moon, the sun is always near the horizon. But that's an advantage. You have areas in the moon that are in permanent darkness and some areas that are in near permanent sunlight. Now, the areas in sunlight are of great value because if you're in sunlight all the time, you can use solar electric power to generate electricity for any kind of surface operation you might have. The areas in darkness are even more interesting because it turns out that they're very, very cold. The only heat that these areas get are the background thermal radiation from space, which is 3 degrees above absolute zero, and then whatever heat flow comes out of the interior of the moon. If a water molecule, or if any volatile molecule, gets into a cold trap, it cannot get out again. Once it's in a cold trap, it's there forever. There's no known physical way to dislodge it. And although it's a very slow process, accumulating deposits one molecule at a time, if you have a very slow process that operates for a very long period of time, you can have significant accumulations. Back in 1994, I was on the Clementine mission, and we didn't really carry any instruments designed to look for water at that time. But what we did have was a radio, so we improvised an experiment to beam radio waves into the dark areas near the poles of the moon and listen to the echoes as it came back. A radio has some interesting properties with relation to dry targets versus icy targets. In a dry target, you will just get a simple reflection. And think of it this way, if I have a book and I show it in a mirror, the letters are reversed. That's because I have one simple reflection, it turns the letters backwards. But if I had to hold the book up to 2 mirrors that are together at an angle, it reflects twice off each mirror and I can read the text. What happens there is you're actually reflecting twice and getting energy, light waves in this case, sent back in the same sense that they were transmitted. We transmitted energy in right circular polarized radio and listened to the echoes in both channels, left and right circular polarized. If you're hitting off dry targets, you should see only the left circular polarized echoes. If you're hitting off ice, the ice is partly transparent. It acts as a reflector, sort of like a bicycle reflector, and some of that energy will come back in the same sense you transmitted it. What we found from Clementine was that, yes, there is that effect near the poles of the moon, which we interpreted as the presence of ice. Now, 4 years later, the Lunar Prospector spacecraft made measurements around the dark areas, and they found enhanced amounts of hydrogen in the dark areas. Hydrogen is a principal volatile element associated with water, and so it's not a far step from these 2 observations to say that there are probably ice deposits near the dark areas of the poles. Now, ice is very important. Water is about 5/6 oxygen by weight. So if you have water, you can not only use it to wash in and drink, you can also use it to breathe. But if you have hydrogen and oxygen, you also have the most powerful chemical rocket fuel known. And by mining the water at the poles of the moon, you can separate the water into hydrogen and oxygen, liquefy it using the extremely cold temperatures you have there, and basically produce rocket fuel. Now, if you produce rocket fuel on the moon, it's totally changing the equation of spaceflight. Right now, if we go to the moon, we have to lift everything, literally every single thing that we need for the entire trip, there and back, with us from the Earth. If you can make propellant in space, make propellant on the moon, and refuel on the moon, you drastically change the equation. And so the goal of going back to the moon is to produce propellant, not only to support human life, to support our activities out there, but also to make propellant to allow us to create a transportation infrastructure to go from Earth orbit to the moon and back, routinely, as much as we want to, as often as we want to. It's basically creating the first offshore filling station. The propellant and water you would make at the poles of the moon, the materials to support an Earth-Moon infrastructure, along with the energy to support operations in Earth-Moon space, fundamentally make the moon a keystone to exploring the solar system.